Hello all, welcome to the channel EduFacts. And in the last video, we have discussed about data structure called linear search. In this video, we are going to discuss about the data structure known as binary search. So, in the linear search, it is not necessary that the array must be sorted, but in the binary search, it is a condition that the array is always sorted. Array is always sorted. So in this technique, what is the basic principle involved? Let us understand first that, and then we will jump to the program directly. So in this technique, suppose this is an array. So we are finding the element by repeatedly dividing it. Like suppose we will divide the interval into half and search for the element. Then again, if the element found at the right of the interval or the left of the interval, then we will cut the array and then we will left out with the remaining array. And then in the remaining array, we will apply the same approach as we have done in the previous one, right? So in this way, we are going to uh, do the search for binary search in a list or in a sorted array. So now the program remains the same as of linear search. In except for the function, we have defined the function as b search, and other than that, the upper program remains the same. The main difference comes in the function definition. So we will be doing the function definition in this lecture and understand the concept. For those who have not understood the previous one, go back to the lecture of the linear search and watch the video. So thank you, and let us start um, the binary search definition. So int beginning comma last comma mid. So we have declared three variables of the integer type. Beginning equal to 0. So why we have made beginning equal to 0? Because we are not starting the search from the beginning. Last equal to size minus 1, because uh, we have to stay in the array size, right? So last is the size minus 1 element. Now here we are going to apply the while loop. So while means up to the mark. So while bag is not equal to last, mid equal to bag plus beginning plus last divide by 2. If now we have to check the condition for the item. If item, again assignment operator. If item equal to not assignment operator, pardon for the last lecture as well, it is comparison operator, not assignment is the single one. So now item equal to AR of mid, return mid. Else if item is greater than AR of mid, what will we do? We will be doing bag equal to mid plus 1. Else last equal to mid minus 1. Return minus 1. Right? Let us now understand the logic. So whatever we're doing, what I have done, we have initialized the three variables beginning, last, and mid. If bag and initialize the value as bag equal to 0 and last equal to size minus 1, and mid value is, what is mid value? Mid value we have not initialized, initialized to a particular value. Instead we have defined the value as mid as bag plus last divided by 2. So suppose first case bag equal to 0 0, last equal to size minus 1. Suppose array size is 5, 5 minus 1 4, so 4 divided by 2 is 2, so mid is 2, right? So we have 5 array and we have seen the same for the 5 array. We have mid position as 2 0 1 2, right? So it is a mid position, right? So in this way we are calculating the mid. Then once we have calculated the mid in the while loop, then the while loop runs up to what? Bag not equal to last means whenever जब तक बैग जो है वो लास्ट के इक्वल नहीं होगा तब तक जो है वो लूप जो है वो चलता रहेगा लगातार, while loop. We keep in mind that the while loop will run until and unless the beginning will not equal to the last, right? So then mid value will be calculated in that same way, and if apply the condition on item, right? What condition? If item equal to AR of mid, suppose whatever element we need going to search, and if the element found at the mid position, then return mid directly. So directly return mid, and it is not equal to minus 1, then a given element found at the index, right? And if else if item is greater than AR of mid, then what will we change? Beginning value change to mid plus 1, so that we can search on the right hand side of the array. And similarly, if mid value is greater than, else the last case remains only the less than 1, so else last equals to mid minus 1, so that we can search on the left hand side of the given array or the given list we are talking about here in the case, right? And otherwise return minus 1, so else return minus 1. So if while loop doesn't works, so it is a rare case when the while loop doesn't works. It is only when beginning is having unusual value or the last having the uh, unusual value, so in that case only. So for here I hope this is clear, and we have understand the very beautiful concept of binary search in data structures in a very simple and sorted manner. So I hope you like the lecture, and please share your feedback in comments on the comment section below, and do like the lecture, and have fun. Thank you.